Today let's discuss about nuclear transport mechanism. Small polar molecules and macromolecules are transported in between nucleus and cytoplasm through nuclear pore complex. Most proteins and RNAs are too large to transport through the complex by passive diffusion, hence active transport system is used. However, only proteins having specific amino acid sequences called nuclear localization signals are allowed. These are the cargo proteins. Nuclear localization signals consist short segments of basic amino acids, mainly negatively charged lysine and arginine. They are recognized by nuclear transport receptors called importins. Importins carry the cargo proteins into the nucleus, binding to specific nuclear pore proteins in the cytoplasmic filaments. The complex is translocated through the nuclear pore inside nucleus. The complex is disrupted by the binding of a protein called RAN-GTP to importin and releases its cargo protein into the nucleus. The importin RAN-GTP complex is then re-exported through the nuclear pore. A protein in the cytoplasm called RAN-GAP stimulates RAN to hydrolyze GTP to GDP. RAN-GDP formed in the cytoplasm is transported back to the nucleus by its own import receptor protein called NTF2. In the nucleus, another protein called RAN-GEF stimulates RAN-GDP to release its GDP and pick up GTP. RAN-GTP can disrupt the binding of importin and its cargo, triggering the release of the cargo in the nucleus. Proteins are targeted for export from the nucleus by specific amino acid sequences called nuclear export signals. They are recognized by receptors within the nucleus called exportins. RAN-GTP promotes the formation of stable complexes between exportins and their cargo proteins. Complex containing exportin, cargo protein and RAN-GTP move to cytoplasm and cargo protein is released by RAN-GAP converting RAN-GTP into GDP. Exportins are then recycled through the nuclear pore complex for reuse. Thank you for watching.
Created using powtoon.